Hello everyone! I'm sorry I couldn't be there again for you guys, but if I can't be there, I figure the next best thing would be to create another vodcast. So here we go. We're going to start today with a warm-up question, so get out your warm-ups, and I also want you to have a copy of a periodic table. So go ahead and pause the video if you need to, but we're doing a warm-up right now. It says, what is the electron configuration and orbital notation for nickel? Alright, let's get started. I know you guys have been learning a lot about the electron configuration, so let's see if we can look at the periodic table and figure out what the correct electron configuration is. So you always start at the very beginning of the periodic table. So let's start here with hydrogen. Alright, the very first period on the periodic table has two elements in it, hydrogen and helium. And I think I already mentioned that helium technically kind of belongs over in this empty space right here. Alright, so this entire area of the periodic table is sometimes called the S block. This area over here, again, just to refresh your memory, is called the P block. The area inside here, where the transition metals are, this is sometimes called the D block. And then down at the bottom, these guys right here are sometimes called the F block. Okay, so let's try to get the correct electron configuration just by looking at the periodic table, because I know you guys can do this. So you always start with the number 1 in the front represents period 1 on the periodic table. And since we're doing hydrogen and helium, which are in the S block, we're going to put a little S. And there's two elements, hydrogen and helium, so we're going to put a little 2 up on top. Okay, after helium comes lithium, and lithium is the beginning of the second period of the periodic table. So the number in the front is going to change from a 1 to a 2. Alright, we're still in the S block when we look at lithium and beryllium, elements 3 and 4, so we're going to put another S. And there's 2 of them, so I'm going to put a 2. Let's continue across the periodic table hitting this area, starting here with boron. You are still in the second period of the periodic table, so the number is still going to be a large 2 in the front. But now, what block have I just hit? You see, I moved out of the S block and into the P block. So the letter S will change to a P. And we're going to go all the way across, count 1, 2, 3, 4, 5, and 6. So the number up top is now a 6. Let's keep going. You've now hit the third period on the periodic table. So the number 2 in the front is going to change to a number 3. We are going to look at sodium and magnesium, which are both in the S block. So this will be an S. And a 2. Continue. Let's hit aluminum. You're still in the third period of the periodic table, so the number will still be a large 3 in the front. But you're now hitting the P block. So we're going to put a P. Let's go all the way across to argon, and you should know that the maximum number of electrons in a p orbital is 6. So we're going to place a 6 up on top like this. Alright, now if we stop the electron configuration at this point, and if you took a moment just to add all of the superscripts that we have so far, 6 plus 2 plus 6 plus 2 plus 2 is 18. You are currently looking at the electron configuration for argon, element 18. But the warm-up wants you to get the electron configuration of nickel, which is right here. So we have still some ways to go. What I'm going to do is I'm actually going to continue up here because I'm kind of running out of room. So I'm just going to kind of continue my electron configuration here, okay? Alright, so let's keep going. We are now going to hit the fourth period of the periodic table. So the number in the front is going to switch to a number 4. And now we are still in the S block, so I'm going to get 2 elements here, potassium and calcium. So I'm going to hit S and 2. Now, I mentioned this in the video that you saw last class. There's a special rule about when you hit the D block, which is right here. When you hit the D block, you see, right now, we are technically in the 4th row of the periodic table. Okay, that's the 4th row. But as soon as you hit the D block, the rule is that you are going to decrease the number, even though you're in the fourth row, you are going to decrease the number from 4 to 3. You see, this is the beginning of the 3D area. So instead of saying 4D, I'm not going to say 4D, I'm going to say 3D. Okay, you see how the number went from 4 to 3. And I already explained why that happens last class. Alright, so let's hit nickel. We want to stop at nickel. So 3D, how many to hit nickel? 1, 2, 3, 4, 5, 6, 7, 8. 3D, 8 will give us nickel. Here is your full electron configuration. Now, let's do the orbital notation. Alright, an s orbital only has one shape, and it is a sphere. So what I'm going to do is I'm going to actually follow my electron configuration to help me do my orbital notation. That's always a very huge recommendation. So if you look here, I'm going to do the 1s orbital. And since it's got 2 electrons, I'm going to put one of the electrons spin up and the other electron spin down. Let's do the next part. This is done. Alright, so it's still an s orbital, so I'm only going to draw one box because the s orbital only has one shape. Just to make sure you know that this is the 2s, I'm going to label it. So 2 electrons, one spin up, one spin down. Alright, that guy's done. Let's do the 2p6. Now a p orbital has 3 different shapes. It kind of looks like a dumbbell. One is sitting on the x, one is on the y, and one is on the z. So to show a p orbital, I'm going to draw 3 boxes because there are 3 shapes. 6 electrons max. So I'm going to label this 2p. Now this should have 6 electrons in there, and it's completely full. So I'm going to draw my 6 electrons, each of them spin up and spin down. That part's done. Let's get to the 3s. 3s only has one box because it's an s orbital. And 2 electrons are in there. Done. Let's try the 3p6. It's another p orbital, so make sure you've got 3 boxes. 3p. And it's full, so we're going to get our 6 electrons in there. All spin up and spin down. Done. Next comes your 4s. An s orbital only gets one box. Spin up, spin down. Done. Alright, now it's time for the 3d8. Now you may have to look at your notes, but a d orbital has 5 different shapes. 10 electrons max. So what we're going to do is we're going to draw 5 boxes. 1, 2, 3, 4, 5. And this will be our 3D. Now if you remember, there is a special rule. It is Hund's rule that says you have to put 1 electron into each box, spin up, before it gets a pair. So I am going to put 1 electron into each box, spin up. 1, 2, 3, 4, 5, before we go back and put them spin down. Now, if you look back up here, it looks like we need to have 8. 8 electrons, and right now I have 5. Alright, so 5. 6, 7, 8. Done. This is the electron configuration and orbital notation for nickel. Now I'm going to teach you a new skill. Go ahead and tuck away the warm-ups and get your notes out. I just have a few things I'm going to show you. Now that you know how to do electron configurations fairly well, we can now move into the next topic, which is going to be Bohr models. I think I already mentioned the basics of what a Bohr model is. It shows the electrons kind of spinning around in like perfect circles. Not super realistic, but trust me, later on when we start looking at how atoms bond, the Bohr model is going to be a huge help because it's all about the outermost electrons. The outermost electrons on an atom determine the atom's reactivity. So I'm going to give you a quick example. The example that I'm going to use is lithium. I want to show you how to do a Bohr model for lithium. And you'll notice that I already drew out the electron configuration for lithium. This is going to help us a lot as we make a Bohr model. Alright, the first thing that we have to do for a Bohr model is we have to draw the nucleus. So grab a periodic table and let's refresh your memory on how to figure out what goes inside of the nucleus of an atom. When you look at lithium on the periodic table, it'll look something like this. I'm refreshing your memory here. Okay, so to get the number of protons, the protons is the same as the atomic number. So we know that lithium has 3 protons. But to get the number of neutrons that are in the nucleus, we have to do a little bit of rounding and some math. We are going to take this number, the average atomic mass, and we are going to round it to a whole number, which means you have to look at the 10th place. If the number in the 10th place is a 5 or higher, you are going to round that value up. And 6.9 needs to be rounded to 7. So we're going to take this number 7, and what we're going to do is subtract the atomic number, because the atomic number represents your protons. So 7 minus 3 is 4. That means that lithium has 4 neutrons. Alright, so let's build this Bohr model. Starting with the nucleus, we are going to tell what is inside of the nucleus first. We have 3 protons, and we have 4 neutrons. Now we are going to start building the rings, and the rings are dictated from the electron configuration. You remember what I told you, that the number in the front right here represents the ring number. And since this is a number 1, I'm going to draw the first ring around this atom. Pretty cool, right? So in the first ring, we should only have 2 electrons. So we're going to get 2 electrons. And there's a rule about how you fill in the electrons. So make sure you are listening, put down your pencils, make sure you're watching me. The very first 2 electrons in any ring always go on the right-hand side like this. I know some of you guys have been taught to draw dots and things like that, but I'm telling you right now, please draw slash marks. They're easier for me to see, they're easier for everybody to see, and if I have to correct and grade your papers, I don't want to have to guess on whether or not there's a dot. So let's make lines instead. It's just easier for me to see those. Alright, technically what we did is we did 2 electrons in the first ring. We did this part, the 1s squared. Let's go on. Looks like we need to draw another ring to represent the second ring. So let's do that. Here we go. I need to only put 1 more electron into that second ring. So remember, the first 2 electrons always go on the right-hand side, but I don't need 2, I only need 1. So I'm going to draw my 1 electron and stop. That right there is the Bohr model for lithium. We're done. Now, I did mention that the outermost electrons are the most important electrons in chemistry. They determine the reactivity of the element. Lithium, by the way, is highly reactive. So let me make sure that you get a vocabulary word in your notes. There's this special word called valence electrons. Valence electrons are the electrons on the outermost ring. Okay, the electrons on the outermost ring. And these electrons determine the reactivity of an element, so they're really important to chemists. Alright, now that I've taught you Bohr models, I'm going to teach you one more thing. Lewis dot structures are a picture that represents how many valence electrons an atom has. And they're really easy to do. You start by giving the symbol of the atom. So we've been working with lithium. The symbol of lithium is a capital L lowercase I. Now I want you to notice that on the Bohr model, the outermost ring of lithium only has one electron, and you see how I place it on the right-hand side. That is exactly the same way that you do Lewis dot structures. I'm going to place one dot on the right-hand side. Voila! That is a Lewis structure for lithium. So I've given you a very simple example. Let's get a little bit more complicated. Let's try to do the Bohr model for sulfur. First things first, grab the periodic table. You can check my electron configuration if you'd like, but what we're going to do is we are going to build the nucleus first. So, on the periodic table, check for sulfur, and let's figure out what should go inside the nucleus. The atomic number of sulfur is 16, so it should have 16 protons. In order to calculate the neutrons, take the average atomic mass, and it looks like the average atomic mass is 32.0, so we're just going to round that to 32, and then subtract the atomic number 16. That actually gives us 16 neutrons. Alright, we're well on our way. Now, let's look at the electron configuration, and it will guide us on how to do the Bohr model correctly. I'm going to build my first ring of electrons. Okay. The first ring only has 2 electrons in it. So, remember where they go? The first 2 electrons always sit on the right-hand side. 1, 2. This is done. Looks like we need to go to the second ring now. Let's do that. Ooh, my rings are not looking very good. Shoot. Let me see if I can try that again. That's a little better. Okay. So, first 2 electrons again on the right-hand side. Done. Looks like we have an issue. We need to get more electrons going. So, I want you again, put your pencils down, bring your heads up, watch the screen, because you have to put them in a very specific order. Remember, I have to grade these, right? So there has to be kind of some rules and some uniformity going on, so watch carefully. I need to add 6 more electrons to the second ring. They need to go in this order. Top, see I'm only doing 1, left, and bottom. This is just like the Hund's rule, 1 electron into each orbital before you pair it up, huh? Now I'm going to go back and pair them. You see? I have now, in the second ring, a grand total of 8 electrons. This part right here is done. Let's move on. Looks like now I need to put a third ring. Alright, here we go. Yay! Beautiful. So the first 2 electrons always go on the right-hand side. 1, 2. That's done. Now let's do this part. 3p4. So remember, this is just like you did before, just like you saw me do before, but we have to obey Hund's rule. 1 electron into each spot before we pair it up. You ready? 1 up on top, 2 on the left, 3 down on the bottom, and now I'm going to come up and give that 1 on the top a pair. Voila! That's the Bohr model for sulfur. Let's do the Lewis dot structure. The symbol of sulfur is an S. Look only at the outermost ring. Outermost ring only. Those are your valence electrons. We are going to do 2 dots on the right, 2 dots on the top, 1 dot on the left, 1 dot on the bottom. This lovely skill that I'm teaching you gets a little bit more complicated once we hit the D block. I want you guys to be able to do Bohr models all the way through the D block. So, let's take a look at manganese. Here's the electron configuration for manganese. let's see if we can make a Bohr model out of this. Let's start always with that nucleus. Let's figure out how many protons and neutrons this guy has. His atomic number is 25, so he will have 25 protons. Let's look at his atomic mass. His atomic mass is 54.9. You guys know that this will round to 55. Now subtract the atomic number. This will give you 30. So it looks like manganese has 30 neutrons. Alright, I've already done the electron configuration up on top. We are going to use that to help us figure out exactly what electrons go where. So let's be really careful. Let's start with the first ring of electrons. The first ring of electrons only has 2 on the right. Done. Let's go to the second ring. The second ring will start with 2 electrons on the right again. Done. Now, let's get the 2p6. Top, left, bottom, top, left, bottom. Done. Looks like we're jumping now to the third ring. Alright, let's get the first 2 electrons on the right. Done. Now, let's get the 3p6. Top, left, bottom, top, left, bottom. Done. Looks like now we are going to need to jump to the fourth ring to get the 4s squared. Alright, fourth ring, coming up. Alright, 2 electrons always start on the right. Done. Now it's time to do this 3d5. Now I want you to notice that the number is a 3 in the front. Make sure that you are going to the third ring. And let me teach you how to do a d orbital. A d orbital, we typically start in the corners, right, diagonal, in the upper right. So I'm going to place, now if you could do me a favor, again, put your pencils down, make sure you're watching. I'm going to put the first electron in the upper right corner. Second electron in the upper left corner. Third goes on the lower left. Fourth on the lower right. And you're like, wait a minute. A d orbital has 5 different shapes, 5 different types, right? So where the heck am I going to put the 5th one? I know, a bit unconventional, but we ran out of space. So it's going to put itself in the lower right here. Those are the 5 spots. Now, right here we are done. This is technically manganese. This is the Bohr model. And if you were curious about the Lewis dot, remember, we only look at the outermost electrons. And manganese and all of the metals in the D block technically have 2 valence electrons, all of them. Transition metals are a little peculiar, aren't they? This is technically the Lewis dot structure for manganese. Now, I always have students who are curious, Mrs. Crowley, what if we weren't doing manganese? What if we went just a little bit further? Why don't we do, like, say, copper? Okay, so let me just help you a little bit out. Okay, if copper is element 29, Cu, and this number at the end will be 3d9. That's what copper is. So, you know, the nucleus will be different. Let's just look at the electrons real quick. How do we make 3d9? Right here we have 3d5. So, if I have to get to 9, I'm going to start again in the upper right. This will be 3d6. Oops, sorry, 3d6. Now 3d7, 3d8, 3d9, and you see how the last one is empty? That right there would be the electron configuration, the Bohr model for copper. Alright everyone, this is the feat de la résistance. This is it. That is all I've got for you. Now, take what you've learned, help one another. Please make sure you help one another. And if you are getting stuck or frustrated, don't hesitate to email me. I really don't mind. It's all good. I hope to be back soon, guys. I sure do miss you. Good luck and have a great Nevada day without me.